students. So in the previous video you have seen, I was telling you the concept of center of mass of discretely distributed masses. Numerical problems I will be solving so that you will understand the concept better, right? Here see, three masses are there, each of mass m, and they are kept on corners of an equilateral triangle. You see, 8 centimeter, 8 centimeter, and 8 centimeter. And we have to find the center of mass of this setup. See, if the masses are same, there is some symmetry. So even if there is no symmetry, right, we can find the center of mass of this. So it depends. Position of center of mass is fixed, but its coordinate depends on the axis chosen, isn't it? So suppose we are selecting the axis passes from this point. Suppose this is x-axis and this is y-axis, and this is the center of mass of this point mass. Here one thing you are supposed to know, that if I am right keeping the mass over here, here and here, what does it mean? That this is the point mass, right? When I say point mass means I am talking about center of mass of this mass, isn't it? So it simply means that center of mass of this mass lies at the corner, right? Suppose this point is A, this is B, and this point is C. C is this corner. So center of mass lies over here at the corner, at this corner, at this corner. Okay? Now, with respect to this axis, what is the coordinate of this? It is 0, 0. Isn't it? With respect to this, if it is x-axis, what is the coordinate of this? That will be 8 and 0. X-axis, there is 8. Y-axis, it is 0. So you want the coordinate of this? Drop. If you draw perpendicular on this is 90 degree. So suppose this point is D. So this is x coordinate, and since it is an equilateral triangle, you must be knowing if perpendicular is dropped from this vertex on this side AB, then it divides this AB into equal halves, or we can say this point bisects AB. So this will be 4 centimeter, this will also be 4 centimeter. The x coordinate of D is known and y coordinate of D is 0. So we are not concerned with D, we are concerned with C. So x coordinate of C will also be 4, and we want this y coordinate. So see, since it is equilateral triangle, this will be 60 degree, isn't it? All the angles will be of 60 degree. Now we see CD upon AD, CD upon AD, or CD upon AC. Either way, we can write CD upon AC, that is equal to sine 60 degree, perpendicular of hypotenuse, and sine 60 we know that is root 3 by 2. Therefore, CD is equal to AC root 3 by 2. And what is AC? AC is 8. So 8 into root 3 by 2, that is goes 4 times. We will go 4 root 3. Means we wanted this and we got the value of this, that is 4 root 3. That is 4 root 3. So what is the coordinate of this now? That is 4 and 4 root 3. So coordinate of all the 3 points with respect to this axis, with respect to this point, I have taken this point as the reference point. So we can find the coordinate of center of mass. So x coordinate of center of mass, as per the definition I have told you, x bar I had written. So here I have written xcm, cm is center of mass. To be more precise, xcm is x1, m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. This was the formula, right, for x coordinate. Similarly for y coordinate also. So m1 x1, suppose we are considering this as m1. So m1 is m simply, and what is x1? X coordinate of this is 0, plus m2 is this, again m, x2 is 8, plus m3 is again m into x coordinate is 4 upon m plus m plus m, that is 3m. So that is equal to how much? This will become 0, 8m plus 4m, that is 12m upon 3m. M and m will go, 4 times will go, that is means x coordinate we got. X coordinate of what? Center of mass. And we will go for y coordinate now. So y cm is equal to, in the similar manner, m1 y1 plus m2 y2 plus m3 y3 upon, simply I will write 3m, adding all the masses. So m1 is again m only, so m1 into 0 for this, right? For this mass again m into 0, y coordinate is 0 over here, y coordinate is 4 root 3, that is m into 4 root 3 divided by 3m. So we will get 4m into root 3 upon 3m, m will go, we will get 4 upon root 3, because root 3 upon 3 is 4 upon root 3. Therefore, coordinate of center of mass is equal to how much? That is 4 and 4 upon root 3. What does it mean? It will be lying on this line somewhere. X is 4, y is something, that is 4 upon root 3, and it will be somewhere here. So this way we found the coordinate of the center of mass of this kind of arrangement of masses. So if we change the axis, then what will be the coordinate? Because position of center of mass won't change. Remember one thing, very important. Position, once you have decided the position, we got the position over here, then position won't change. But with reference to the coordinate axis, coordinate will go on changing. With respect to this is the coordinate. If we change the coordinate system, because axis we change, then what will the coordinate of that center of mass? That I will look at. For the same problem, I will change the coordinate system, and then I will say what is the coordinate of that center of mass. Okay? See, in the same question, I have changed the coordinate axis. Now, this is y-axis and this is x-axis. And this point D is the origin. This is 0, 0. Then what will be the coordinate of center of mass? Clear? Previously axis was here. Now axis is shifted, it is changed. Position is changed. Then what is the coordinate of center of mass? Here you see, since this is the origin, so this is positive direction, this will be negative direction, I will say. This is x dash in this case. So all the measurements done in this direction and in this direction will be positive, in this direction and in this direction will be negative according to the coordinate system. Right. So I will write the coordinate of all these points A, B and C wherever masses are kept. Right. I'll repeat one thing. Just nicely get it embedded in your mind that whenever I talk mass is kept over here, then I am talking about center of mass if of this object lies at the corner of this triangle, right? Here, what is the coordinate of this point? With respect to this coordinate system, 0 is here, negative direction, this will be minus 4, 0. It is on x-axis, opposite direction, this is minus 4. In this direction, this will be 4 and 0. In this direction, that is x coordinate is 0, y coordinate is 4 root 3. It's very important which axis you have chosen, and about that axis you are writing the coordinates of the center of masses of the masses, scattered masses or discrete masses, right? So this is minus 4 0, this is 4 0, this is 0 4 root 3, because x coordinate is 0 over here, y coordinate is 4 root 3, so that I have mentioned. So now I will write xcm. Again, m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. See, for this mass if I take, for mass kept at A, that is m into minus 4 plus this one m into 4 plus this one m into 0. X coordinates I have taken of all the three, x coordinate upon this will be 3m simply. Now you see m into minus 4, that is minus 4m plus 4m plus 0 upon 3m. This will go, numerator becomes 0, means x coordinate is 0. If the reference axis I changed, x coordinate of center of mass got changed. Now we will go for y coordinate. YCM is equal to what? In the same way, m1 y1 plus m2 y2 plus m3 y3 upon 3m, again total mass, that is m into, what is y coordinate of this? That is 0, plus m into y coordinate of this is again 0, plus m into y coordinate of this is 4 root 3 upon 3m. Here 4 root 3 upon 3. It is m, and will go, you will get 4 upon root 3. Therefore, coordinate of center of mass is equal to what? X coordinate is 0, y coordinate is 4 upon root 3. Coordinate axis changed and coordinate of center of mass got changed. So center of mass will be here somewhere, that is this is center of mass. This coordinate with respect to different axes will be different. What will be different? Position will not change, but coordinate will change. Is it clear? So I will take different kinds of arrangement of the masses and will find the center of mass. See another arrangement of masses. This is ABC is an isosceles triangle. Isosceles triangle means two sides are of equal length, that is 6 centimeter and 6 centimeter, and this angle is 30 degree, right? Then we have to find the center of mass of this arrangement, where at these corners it is 5m, it is m, and it is 4m. Right? Question is quite similar. This as y-axis and this as x-axis. Then with respect to this axis, we have to find the coordinate of the locations where masses are kept, or we can say the coordinate of the corners of the triangle. Either way, because center of mass of this lies at this corner, center of mass this lies at this corner, and similarly center of mass of 5m lies at corner A. So with respect to this, if I look at this, I have chosen at origin of this coordinate system. So I will write coordinate of this as 0, 0. What is the benefit of taking coordinates? So that after using the formula, it becomes quite simple, easy to use the formula. Coordinates are known, only x, y, and xy are there. So you can use formula directly, right? Need not know what is the distance of this mass, what is the distance of that mass from this axis, All those things are not required to be done once coordinates are written. Finally, we are using the coordinate, right? We are using the value of x and value of y. In this plane, all these masses are kept, triangle is in this plane. Right. See, the coordinate of this with respect to this axis is 0, 0 because it is chosen as origin. And its coordinate is, I have to take this distance complete from here to here. So to find that this distance, we will use this triangle ACD. In ACD, I will find CD also. For this mass, what is the coordinate of C? I will write. So we want this distance as well as this distance. And one thing we know, then in isosceles triangle, if this from this vertex is perpendicular drawn on AB, right, that will be perpendicular. It will be bisecting this side AB. In geometry you have studied. In isosceles triangle, if from this vertex perpendicular is drawn, then this point bisect this line segment AB. There you have already studied. So you will find AD and CD. So we can see AD upon AC is equal to cos of 30 degree. AD upon AC is equal to cos 30 degree. And cos 30 we know that is root 3 by 2. Therefore, AD is equal to AC into this, and what is AC is 6. So 6 into root 3 by 2, that is 2. 3 times it goes, that is 3 root 3. AD is 3 root 3, and we will find CD also. So CD upon AC, that is equal to sine 30 degree, and sine 30 is half, that too we know. Therefore, CD is equal to AC into half. AC is 6, 6 into 1 by 2, that is equal to 3. So we got AD, means this is 3 root 3, and this is AD, and CD is 3. So this height is 3. The coordinate of this is how much? 3 root 3 and 3. And since this is 3 root 3, this will also be 3 root 3. So coordinate of this is 6 root 3 and 0. Total distance 3 root 3 multiplied by 2, that is 6 root 3, and y coordinate is 0. So coordinates of all these points are known. Once these coordinates are known, finding coordinate of center of mass is very easy now. So x coordinate of center of mass I will get, that is m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. That is m1. I will consider this mass 5m. Coordinate of this is 0. So 5m into 0 plus m2, this mass. M into x coordinate is 6 root 3. 4m into x coordinate is 3 root 3. Divided by how much? M1 is 5m. 5m plus m2 is m plus m3 is 4m. Okay? So, this is 0, 6m root 3, 6m root 3 plus 12m root 3 upon, how much it is? 10m. Right? So, m will go. So, this will be 18 root 3 upon 10, or 9 root 3 by 5. So YCM is equal to, again in place of x there will be y. So m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. Put the values now. M1, that is 5m into 0 plus m into, here again this is m2, again 0 plus m3 4m, that is 4m into y coordinate is 3 divided by simply 10m I will write. Okay, sum of the masses is equal to 10. So that is equal to 12m upon 10m. So m and m will go to 1.2. If these lengths are in centimeter, so we will get this as centimeter, this as centimeter. So therefore coordinate of center of mass, that is equal to x coordinate is how much? That is 9 root 3 by 5. This can further be simplified. Okay, 9 root 3 by 5 and y coordinate is 1.2. So this is the method of finding the center of mass of the discretely distributed masses. See, this is another question I have taken. That is, the shape of this is, what is the figure? Do you remember? In geometry you have studied in lower classes. That is trapezium. These two sides are parallel. This is one side. This is making angle 37 degree. And at the corners of this figure, the plane figure, these masses are kept. M, 2m, 3m and 6m. And we want center of mass of this setup of masses, discretely distributed masses. So in the similar fashion I will go. First I will select the axis. Suppose if I am taking this axis. One thing you have seen, I am keeping origin at one of the masses. It's not like that. You can keep the origin at any place. As I had shown in the previous case, in case of the triangle, isosceles triangle, equilateral triangle, anywhere you can select the origin. And from there distances will be measured. That's it. Nothing else. Right? So selection of origin you can do as per your choice. So I am feeling it is convenient to choose over here. That is I have chosen. I can choose over here also, here also, here also. Anywhere origin can be chosen. But you should be able to measure the distances of the rest of the masses from that origin. That is important. If you are selecting origin over here, so it is, you will be in position to measure the distance from here to here. From here to here. Then only you can find the coordinate of the center of mass. So selecting origin is not the problem, but problem is from that point of origin, you should be able to measure the distances of these discretely distributed masses. That's important, right? So that is why for my convenience, I choose this point as origin, right? So we have to look at from here, we will be comfortably able to measure the distances of these discretely distributed masses. I am realizing. So from here I can find this distance also, and for this also, this and this. So that is why I have chosen this. Are you getting my point? It's very important, you should know it. Now see, this is 37 degree. If I draw perpendicular from here on this side, then this will be a right angle triangle. Suppose this point is E. And now this is 90 degree, this is 90 degree, this is 90 degree. So naturally this will also be 90 degree. All the four angles will be 90 degree. It means this figure DEBC, it is either a square or rectangle. That way we look at whether it is a square or rectangle, that will be seen later. But it will be either a square or rectangle because all the angles of these corners, at these corners it is 90 degree. Okay. Now we will find the distances, this DE and AE. So AE upon AD, AE upon AD is equal to what? Cos 37. And cos 37, if you remember, I have drawn this figure many times, this triangle. See, if it is 90 degree, this is 37, that is 3, 4 and 5. Standard triangle for this kind of arrangement. So this is 5, then this will be 4 by 5 cos 37. Therefore AE is equal to AD into 4 by 5. AD is 5, so 5 into 4 by 5, that is equal to 4. So this is 4 and then this will be 3. And see, since this is perpendicular to this is also be equal to 3. This is also 3 centimeter. This is 4 centimeter. This will be 3 centimeter. This is given 6 centimeter. So this will also be 6 centimeter. So see, for all the masses, distances are known. So we can find the coordinate of all the corners. So coordinate of this will be 0, 0. Coordinate is x-axis. So coordinate of this point B will be 4 plus 6. That is 10. Y coordinate is 0. Here coordinate of this is x is 10. Y is 3. That is 10, 3. Here x is 4. Y is 3. That is 4, 3. Coordinates are known. You can find the center of mass. Important is this, how to find the coordinates of these center of masses, of individual masses, right? Scattered masses, discretely distributed masses. Center of mass lies at this corner. Center of mass lies at for these masses, right? So you should be able to measure the distances from the origin of the coordinate system. So XCM, again same formula, M1, X1. So M1 is M, X1 is 0. So M into 0 plus 2M, this 2M into 10 plus here 3M into 10, 3M into 10 plus 6M into 4, 6M into 4 divided by sum of all the masses, M plus 2M, M plus 2M plus 3M plus 6M. That is equal to C. This will become 0. This will become 20M plus 30M plus 24M. 20M plus 30M plus 24M. How much it is? 6 and 6, 12M. Right? So all M's will go. So you will get 20 plus 30. It is 50. 50 plus 24. That is 74 by 12. So we can simplify it to 37, 6. That is 37 by 6 centimeter. You can write in the mixed fraction also. So 2 3 are 6, 2 4 7 are. So this is x coordinate of the center of mass, then the y coordinate of center of mass you can get. So again m into 0, m into y coordinate is 0, and plus 2m into y coordinate is again 0, plus 3m into y coordinate is 3, plus 6m into y coordinate is 3 over here. So total mass is how much? That is 12m. Simplify this. This is 0, this is 0, that is 9m plus 18m by 12m. 18m, 9m by 12m, all m's will go. We can write that is 27 by 12. So 3 4s are, 3 9s are, that is 9 by 4 centimeter. So what is the coordinate of center of mass? Therefore, coordinate of center of mass is equal to x coordinate is this, that is 37 by 6, and y coordinate is 9 by 4, and this is the answer. We'll make next time. Till then, all the best. Take care of you.